Good morning, dear students. Welcome again. Today I will discuss some numericals based upon electrolysis. Such numericals are very important for your board examination point of view. So our first numerical from NCERT 3.13. How much electricity in terms of Faraday is required to produce first number 20 gram of calcium from molten CaCl2, and the second number 40 gram of aluminum from molten aluminum oxide. From first question we can write what? CaCl2 is given electricity supply, it converted into calcium 2 plus 2Cl minus. At cathode, calcium 2 plus, except 2 electron converted into what? Calcium. It is 1 mole. It is given 2 mole of electrons. We know that 1 mole of calcium is equal to 40 gram. Here we can write what? 2 Faraday. So we can write 40 gram calcium obtained from 2 Faraday. Therefore, 20 gram calcium, because in question 20 gram calcium is given, equal to 2 by 40 into 20 Faraday means what? 1 Faraday. So 1 Faraday electricity is required for the conversion of CaCl2 to Ca, and the weight of Ca is equal to what? 20 gram. Our second question, Al2O3 is given. If electricity supplied, it converted into at cathode, reduction occur for metal, and it is given what? 2 mole. It is 6 mole of electrons. 2 mole is what? 2 into 27 gram. 6 mole of electron means what? 6 Farad. We can write what? 2 into 27 gram aluminum obtained from 6 Farad. Therefore, according to question, 40 gram aluminum obtained from 6 by 2 into 27 into 40 gram aluminum, that is 4.44 Faraday. So 4.44 Faraday electricity in terms of charge is supplied, then molten Al2O3 converted into aluminum, and the weight of aluminum is equal to what? 40 gram. Our next NCERT problem 3.15. The question is, a solution of nickel nitrate is electrolyzed between platinum electrodes using a current of 5 ampere for 20 minutes. What mass of nickel is deposited at the cathode? This problem is based upon Faraday's first law of electrolysis. Why? Because time is given and a relation become developed between weight and time with the help of current and electrochemical equivalent. So according to question, NiNO3 whole twice is given and 5 ampere current supply. It converted into nickel 2 plus 2 nitrate at cathode. Only reduction occur. Nickel 2 plus except 2 electron convert into what? Nickel. The weight of nickel deposited is equal to suppose x gram. T is given 20 minutes. Means what? 20 into 60 seconds. Generally, time is taken in second in Faraday first law of electrolysis. Our expression becomes W is equal to Z into C into T. W is equal to E by F into C into T. Where W will deposited, E for nickel atomic mass upon charge या number of electron except 2 to 59 by 2 for Rade value 96500 coulomb, current 5 ampere and T is 20 into 60. If we solve, we get the value of weight, that is 1.82 gram. W is what? Weight deposited in gram. So this is a way to solve problem with the help of Faraday's first law of electrolysis. Our next NCERT problem 3.16. 3.16. 3 electrolytic cells A, B and C containing solution of zinc sulfate, silver nitrate and cupric sulfate. Respectively connected in series and a steady current of 5 ampere was passed through them until 1.45 gram of silver deposited at the cathode of cell B. How long did the current flow? This is our first question. And the second one, what mass of copper and zinc were deposited? This question is combined form of Faraday's first law of electrolysis and Faraday's second law. According to question, Three electrolytic cells are given: A, B, C. In first cell, ZnSO4 electrolyte present. In second cell, silver nitrate electrolyte present. And C cell, COSO4 electrolyte present. This deposited zinc, this deposited silver, and this deposited copper. When same current is to be supplied, that is 5 ampere. Suppose weight of copper deposited x gram, zinc y gram, and the weight of silver is given, that is 1.45 gram. So from cell V, we can write W is equal to E by F into C into T. Weight of silver 1.45, E is equal to 108 by 1, Faraday 96500. Current is 5 ampere, T is unknown. If you solve, you get the value of T in second, that is 863 seconds. So from Faraday first law of electrolysis, we can calculate T. From cell A and B, we can write what? W1 by W2 is equal to E1 by E2. Weight of zinc Y, weight of silver 1.45, equivalent weight of zinc 65.5 by 2, and E2 is what? 108 by 1. By solving, we get the value of Y, that is 0.44 grams. That is the weight for what? Zinc. Similarly, W1 by W2 is equal to E1 by E2. If we consider cell B and C, 1.45, this one X, E1 is equal to what? 108 by 1, and the weight of copper, atomic mass 63.5 by 2. If we solve, we get the value of X, that is 0.426 gram. That is weight of copper deposited. You know very well, E silver is equal to 108 by 1, E copper is equal to 63.5 by 2, E zinc is equal to 65.5 by 2. Equivalent mass of metal is known. Then with the help of Faraday's second law of electrolysis, we can find out the weight deposited. This topic is very important in electrochemistry. Suppose more than one cations and anions are available for discharging, then only one cation deposited at cathode and only one anion deposited at anode, which is known as selective discharge of the ions. The preferential discharge of the ions present in an electrolyte at the respective electrode is also known as selective discharge of the ions. Factor effective selective discharge. Our first factor is relative position of cation or anion in the electrochemical series. You know very well what is electrochemical series. The element which are present below hydrogen in electrochemical series easy to discharge. It means they are deposited at their respective electrode become easier. Suppose electrochemical series is given potassium and calcium, sodium, magnesium, aluminum, zinc, iron, hydrogen, copper, silver, gold. This is the order for deposition. Increasing order of deposition. Suppose negative ions are given like sulfate, nitrate, OH, choline, bromine, iodine. This is also what? Increasing order of deposition. You can write also what? Discharge. Suppose in solution copper 2 and H plus are present. Copper 2 and H plus. Copper 2 ions present below hydrogen. Therefore, copper 2 ion become discharged at cathode. Similarly, if we consider sulfate ion and OH minus ion, OH ion is below sulfate. Therefore, OH ion discharge at anode. We know very well our modern electrochemical series is based upon increasing order of reduction potential value. Lower the discharging potential, easy to discharge. Lower the discharging potential, lower the discharging potential, easy to discharge, or you can say greater the reduction potential, easy to discharge of such metal, or you can say non-metal at respective electrode. Our next factor is concentration of ions in electrolyte. Higher the concentration of ions, greater the probability of it being discharged at respective electrode. Suppose if we take dilute NaCl, it means in dilute NaCl, NaCl and water both are present. NaCl dissociate as Na plus and Cl minus, water dissociate as H plus and OH minus. If we consider cations and anions, the reduction potential of H plus ion is greater compared to sodium ion, or you can say hydrogen ion is below compared to sodium ion in electrochemical series. Therefore, at cathode, H plus ion become discharged. If we consider anion, then Cl negative is below to OH minus ion. That's why Cl minus ion discharge at anode. But if concentrated NaCl solution is given, here there is no role for solvent. So only Na plus and Cl minus are responsible for electrolysis process. So we can say at cathode Na plus ion discharge, whereas at anode Cl minus ion become discharged, that is deposited. Our last factor is nature of electrodes. Two types of electrodes are used in electrolysis process. The first one, inert electrode. Second one, active electrode. Inert electrode means what? Such electrode itself do not take part in electrolysis reaction. That is, iron, graphite, platinum, etc. are called inert electrode. Whereas active electrode itself take part in electrolysis reaction. That is, copper, nickel, silver, etc. are called active, or you can say what? Reactive electrodes. Suppose let us consider electrolysis of copper sulfate solution. Electrode at cathode Cu, anode Cu. It means what? Reactive electrode is used. So at anode itself copper is take part. But when electrolysis of copper sulfate solution take place, here anode is treated like what? Inert PT. So at anode, if we consider sulfate ion and OH ion, both are responsible for electrolysis, then we can say that OH ion become discharged at anode. Why? Because OH ion below in the electrochemical series compared to sulfate ion. So at anode, 4OH minus converted into water O2 and 4 mole of electron become released during electrolysis process. So this is the way for electrolysis when more than one cation and anion are available for discharge. Thank you.